Okay, good morning or good afternoon, good evening, everyone. Welcome back sa ato ang course. And we'll continue on our discussion on chapter 2 na ta. So that would be on electric fields in matter. Okay, so atong discussion good sa electromagnetism 1, the whole discussion of it was centered around calculating the electric field or electric potential or energy of the system, calculating the work done in an isolated case, meaning we calculated the electric field at a given point in space wherein it's vacuum or empty. But this time, what will happen to the electric field? So how will you be able to calculate it in the presence of a certain matter, let's say molecule or an atom maybe, and a much more complicated than that would be a dielectric, okay, which is our main interest for this particular lesson or topic. Okay, let's proceed. Next, reviews. Okay. So most of the matter or substances respond to an electric field. Okay, mo respond siya sa electric field when exposed to it. And one good example for that is a conductor. So when a conductor such as copper, okay, copper matong ginagamit sa atong electrical wirings, when subjected to an electric field or difference in potential, these charges will start to move and that creates a current. That's why we have a current. With the presence of the electric field, these charges will respond or react to to the to the external electric field. And for a conductor, it has an unlimited supply of free charges. So daghan kay siya free charges that roam around on the surface sa imuhang conductor. So that's why gamit kay siya sa electrical wirings because of the presence of this free charges. And these charges are not associated with any particular nucleus, okay? So they just roam around freely, okay, randomly. And then when with the presence of the electric field and all of these free charges will begin to sense the electric field and feel the force, okay? And it will move from higher potential to lower potential. And we have another type of um, actually tulo na siya ka-type. We have semiconductor also, and for this case, we'll focus on the insulator, particularly on the dielectrics. Okay? Mao na siya ang ginagamit sa mao na siya ang ginagamit ng material in making a very good capacitor. Okay? So all charges are attached to a specific atoms or molecules in this particular setup sa mga insulator. So that's why insulator is a very bad conductor. It doesn't conduct electricity. However, gamit siya in a sense na it will not allow a flow of charge. So it can give protection sa imuha if in case mahikapan mo conductor. So dili ka ma-electrocute because na may insulator. Now another purpose also of the insulator is dielectric. So this is a typical one form sa mga dielectric. So we have a capacitor. So I hope ma-recall niyo ang idea sa kung saan capacitor all about. So ang capacitor two is composed mainly of uh, two opposing plate of two plates of opposing charges. So we have kung Q na siya din ha, then this is negative Q na siya diha. Okay? And then na siya electric field na yung direction in that case. So that's a capacitor. And if you want to improve the performance of this capacitor, that's why they will insert other electric material in between. Okay? So mo na siya nga case din eh. The dielectric is this one. And this is the thin metal foil. That's your conductor. Okay, this is your conductor. And this is your insulator. Now, This material, this dielectric, or even molecules or atoms, when exposed to an electric field, it will react. Okay? Lahi-lahi ang iyang ma-feel or ang reaction depende sa type of atoms or molecules or material. Some would be stretched, ang individual atoms or molecules, and even some will rotate. Okay? Now, this is how they react. They stretch or they rotate, and then we'll be able to find out later anong iyang mechanism and what this has to do with because of the presence of this electric field, and then we'll try to calculate and quantify this stretching and rotation and calculate the effect in general sa imuhang atom or molecule. Okay. So what happens if an atom is exposed to let's say to an external electric field? So let's say atom lang sa siya. So when electric field is present, you would say nga, well, it will not be affected, would they? Since the atom is neutral. Okay, atom is neutral. It has positive on the inside and negative sa iyang shell. And in quantum mechanics, they call it the electron cloud of the atom, in this case, the hydrogen atom. Well, actually, affected siya. Okay? Okay, why did I say, saan siya dira? Well, it will not be affected. Actually, the answer is no, meaning ma-affected siya. Okay, that's the scenario there. Now, the atom is technically neutral, but take note that it has positive and negative as its component. And with the presence of the electric field, it will cause the electrons to be attracted towards the electric field. Okay, so this is the electric field in this kanisang figure. So if this is your electron cloud, ang imuhang response sa imong electron cloud or electron will be opposite to the direction of the electric field, right? Mao na siya ang imuhang tara. And then also ang effect sa ang response sa imuhang nucleus, which is positively charged, it will be shifted or dragged in the direction of the electric field. So mao na siya ang case dinhi. This is the electric field. This is the direction of your the shifting of your positively charged, which is in the nucleus. So ang effect niya is mo siya ma-stretch, right? Mag siya niya ma-stretch niya literally. So in both directions. So the electron cloud is trying to stretch the atom in the left direction, while the positive charge in the nucleus will try to stretch the atom in the right direction. Okay, so in principle, if the electric field is very large enough, it will cause the atom to be ionized. Okay, when you say ionized, matangtang yun ang iyahang electron completely. So it can pull the atom apart and the substance becomes a conductor. Okay, so nana siya free electron. Okay, pull apart na gini mo ang electron sa iyahang atom if the electric field is very large enough. Okay, and because of this, because of this external electric field, the atom becomes polarized because na-separate nimo ang imuhang positive and negative, or na align nimo siya sa imuhang direction sa electric field. So in this case, the atom is now polarized. Hence, the nucleus is now shifted at a particular distance. Okay. So let's say, mo ni siya ang center. So ma-shifted na imuhang nucleus, let's say a distance A from the center. So if that is the case. And let's say assuming lang ang imong electric field is not so large enough na dili pod ma-pull apart ang electron sa imuhang atom. So just sakto lang siya nga strength sa mong external electric field to make the atom polarized. Now, in this case, the atom now has a tiny dipole. Okay? Diba, na-discuss naman ta sa previous nga lecture on what a dipole moment is. So please refer to the previous video. Okay? So you have na siya dipole, meaning you have a plus and negative. So say that's a dipole separated by a distance, let's say A. And the dipole moment P is pointing in the direction of the external electric field as shown here, right? So this is the direction of the uh, dipole moment. This is also in the same direction with the external electric field. Okay, that will always be the case. Okay. So natural dipole moment, and it is given by this formula. So we'll try to derive this later. Okay. So technically, this is the dipole moment formula, where alpha is the atomic polarizability and the ability sa atom kung usa siya kadali ma-polarize. Okay. Or makatong inaniman ang case sa ma-polarize, right? It's like ma nakay at negative and positive nga charge in opposite direction separated by a particular distance. So if wala ni siyang electric field, the atom is not polarized because your electron is just, say, in an electron cloud is moving randomly around. So this is a classical pa ni siya nga model. Dili pa gani siya quantum. Okay. So with the presence of the electric field, it somehow ma-fix nimo or ma-align nimo ang direction sa ihang dipole moment, which is ng negative na adinhi and the positive is padulong din ha. So this is the direction of the uh, dipole moment from negative to positive. The same direction also kung asa nag-point ang external electric field. Okay? So alpha depends on the detailed structure of the atom. Depending on the atom, kung unsa pod ang iyang value sa iyang alpha or the atomic polarizability, on how well the atom will be or how easy is it the atom to be polarized given say a unit of measure sa mga electric field. So we'll take a look at this example. Kato na example kaganina pod. So you have a primitive model. When you say a primitive model, it doesn't take into account the quantum mechanics nga view. It's like mo siya planetary nga model. Okay? And we'll consider nga ang density sa imuhang atom or the electron cloud is uniform. Let's say let's say the charge density of the electron is given by the charge over the total volume. In this case, the volume of a sphere ay atong i-consider ani. Okay? So we have a primitive model for an atom consists of a point nucleus surrounded by a uniformly charged spherical cloud of radius A. Okay. Now calculate the atomic polarizability of such an atom. Now, quick facts about the scale or size of the atom. So the size of the atom is around 10 to the negative 10 meter, while the size of a nucleus is 10 to the negative 4 meter. That's dako kay siya og difference, okay? That's why they would say that atom is mostly empty space. Okay? So it's like ang iyahang analogy is the analogy is like this. The atom is the soccer field, while your nucleus is your 10 peso coin. Right? So dako kay siya og difference, but dako ra kayo ang atom compared sa ihang nucleus. Okay, that's how the scaling is. So we'll try to solve this one. Open this note. Okay. So we'll have our problem na atay atom. Okay. Let's draw a circle. Wait, okay. So we'll have an atom, and at the center you have charge Q, and then the radius is A for the electron cloud. So the electron cloud is your charge negative Q. And then naa siya'y ato na i-expose og electric field, right? Let me draw a circle once again. Okay. So with the presence of the electric field, ano ang imong electric field? External, okay, electric field. So the electron cloud feels a force in the direction opposite sa imong electric field. So naa din ha. So this is, let's say, F E. F force nga ma-feel on the electron. Okay? And sa imong sulod, pang nucleus, naa siya'y dito. So, right? So this is the force sa imong this is plus sa imong nucleus. And of course, because maka-feel man og force ang nucleus due to this presence of external electric field. So ma-display siya at a distance, say distance d. Okay? Mo na yung displacement, ma-move siya away from the center and say distance d na siya. Okay? So this is electron cloud of charge negative Q. Negative Q, that's the electron cloud. Okay? So the nucleus will experience a force since it is shifted a distance a or a distance d from the nucleus. So mo na ihang ma-feel nga, so this would be the, say, this is force external. This is force due to the external force is equal to positive Q sa nucleus, and because of the presence of this external field, right? Pamani mo equation sa force, di ba? Na if you recall sa ito ang first discussion, first topic, or even sa general physics, if naka-discuss mo ng electromagnetism nga part, force is just QE. Okay? So the charge under or in the presence of an electric field. So in this case, the force due to the external field, and then this is your nucleus charge, and this is the electric field external. Okay. So for the electron cloud, as I said kanina, it has a constant charge density for the electron cloud. So na siya charge na negative Q over the total volume of the electron cloud. And the volume of the electron cloud is just a sphere, and the volume for the sphere is just 4 pi a cube, a man ang radius, over 3. So simplifying that, we get 3q over 4 pi a cube. Okay? I hope naka-follow ra. Wala ni i-ana din. Hence, we can calculate for the electric field sa electron cloud. We will label it as, say, minus for the electron cloud. electric field inside. It's given by the Coulomb's law, a formula. You have rho d tau, right, over r squared, and this is si r hat. So, imo nang i-integrate by substituting rho. Ang rho na to is kaniman. This one, this is our rho. So that would be 1 over 4 pi epsilon naught rho. So since uniform raman ang volume, o imong uniform ang distribution sa imong charge, then we can take rho out of the integral and then integrate d tau. And since uniform raman siya o uniformly distributed, d tau is just the volume, right? Over r squared. Okay. And the integral is from 0 to r. Okay, sa imong Gauss law. So this is from 0 to r. So your rho is negative, right? Negative 3q over 4 pi a squared. Ano siya r squared ha? So butan akong r squared din eh. And ang v nimo is just 4 pi r cubed, right? Over 3. So simplifying these terms or this factor here, mo cancel ang 3. Cancel po ang 4 pi, right? Cancel ang 4 pi diha. And what else? The r cube ma-cancel po. So r na lang na siya. So we are just we are left with qr over 4 pi epsilon naught. This is a cube, right? A cube. Okay, this would be this is negative ng electric field. So this is the electric field now sa imuhang electron cloud or minus. So then let me just erase this one. Then notice also that based sa kaning figure, right? With the presence of the external electric field, nga sakto lang siyang electric field, nga enough ra pod nga mabalance bitaw dili pod totally ma-rip out ang imong electron cloud sa atom. So in this case, mo-attain siya og equilibrium. So di na siya mag-move. So in that case, mabalance out na ang force sa Fe og force sa kaning sa positive, right, sa nucleus. So mabalance out siya. So that would be the F minus would be this one, right? Which is kanisa, this is the X external kanisa imuhang you call this kanisa imuhang nucleus, right? Also from this electric field we can calculate the F minus, which is Q E minus, and imo naman siyang i-substitute. That would give you negative 1 over 4 pi epsilon naught. This becomes Q square, okay, and so I put here D because this would now be the force of the electron cloud on the nucleus. And this is the shift, right? The shifted distance. It's given by this equation. So we need to settle this. We have F minus plus the F external is equal to 0. So substituting the formula, the one that we got a while just recently, sa imuhang F minus. So we have negative 1 over 4 pi epsilon naught q squared d over a cube plus your F external is just Q external electric field that's equated to 0. So simplifying this one, we will be able to get the displacement or d, the distance d. So we have Q squared d over a cube. Balin sa pikas, we have Q external. Then we have 4 pi epsilon naught over Q. Napa na siya times a cube. Right? So simplifying na to, ato na siya oh, wala pa na ako nabutang a cube naman siya diri. Simplifying d, we have 4 pi epsilon naught a cube over q. Then this is the external. Right? So from this, we get the distance d. We can calculate the induced dipole moment sa imuhang atom because of the presence of this external electric field. So we erase this. So the induced dipole moment, from previous lesson, we discussed about the dipole moment formula for discrete charges or point charges. That would be for dipole, we have QD, right? And where D is given by this. So substitute na nimo, we have 4 pi epsilon naught a cube E external. Okay. Or we can just simply say that this one is some constant. We have alpha E external, right? Which is what man atong gikuan last time, right? Tara, alpha E external or E electric field. So alpha is kanira man na your atomic polarizability. Okay, if you compare this to the actual nga atomic polarizability of a hydrogen atom, if you use this equation, dili siya exact makuha but actually close, okay? And that would be reasonable because anyway atong model gigamit is not actually accurate for we start simple naman and we only consider nga our model is a primitive atom like electric cloud of radius A and then uniform ang ihang charge density, right? Later on, we'll try to calculate it in a more realistic way. Okay. So we have calculated the polarization of an atom and we extracted or calculated the dipole moment of that single atom. So primitive model naman atong gigamit, right? But for the case of molecules, so it's not quite so simple anymore. Okay. lahi man ang polarizability sa imong molecule if ang imong electric field is directed at different angles. Okay? Like for this case, consider the carbon dioxide. The polarizability of the polarizability of your molecule is different if it is directed in this direction. Kani? If kaning direction, that's 4.5 of this 4.5 times 10 to the negative 40 of this unit. And gamay ang ihang polarizability if directed perpendicular. Okay? Let's say sa y-axis and this is for x-axis. Okay? So when the field is directed at some angle, let's say kani siya is perpendicular and parallel, what if paslant siya at a certain angle? You have to get the perpendicular component and the parallel component of the electric field. So medyo complicated gamay. But it can be done. Okay? So for a completely asymmetrical gid nga molecule, your dipole moment alpha E becomes like this. Okay? So this is the most general equation for finding the dipole moment and the component of the dipole moment in x, y, and z. So we have alpha xx, alpha xy, and so on, right? And this can be represented in a matrix form, or your alpha ij is your polarizability tensor. Okay, it's a tensor of rank 2. So rank 2 siya nga tensor. So kabaw naman mo unsa ng tensor, right? Na-discuss na ninyo sa inyong mathematical physics. So note that large alpha ij would mean if large electric field is along the j direction, it would greatly polarize the molecule in the highest direction. Okay? So let's say alpha yx, tara. Sa alpha yx, if if you have large electric field in the x direction, that would mean uh, mas masayon baga ang dako ang polarizability, the ability nga imong molecule to be polarized in the y direction. So wala siya nga case. If you have say alpha yx is large, that would mean if large ang electric field in that direction, it would greatly polarize the molecule in this direction. Okay? Ma-polarize siya ana in that direction. So mas dako siya o polarizability, okay? So to speak. And so on. If you have alpha zx, alpha xy, and so on. So another example, so this is a more a more realistic nga model dayon sa ato ang hydrogen atom. Okay? So in quantum mechanics, the electron cloud for a hydrogen atom in the ground state has this density. I don't know if na-derive din ninyo sa inyong quantum mechanics, but for this purpose, ato ang topic sa electromagnetism, but we'll just have to accept and use this. Okay? And we'll accept this as a fact, and it's true that this is the electron cloud charge density, okay, of your hydrogen atom, where Q is the charge of the electron and A is the Bohr radius. Now find the atomic polarizability of such an atom. So, the same gihapon siya nga idea actually. Ato ang the same picture but ang iyahang the same picture of an atom, but in this case ang imuhang charge density is given by this form. So it's not a constant anymore, hindi na siya uniform. Okay. So first, we need to calculate the electric field of the electron cloud. Say kani siya nga kuan notation. Then expand the exponential, assuming that R is much less than A. And if you have time, you can even search for the source. Okay, mas sophisticated din siya na approach. But in our case, we'll try the simpler approach. Okay. I'll try to look into that. Okay. So because of the electric field, the nucleus will be displaced a distance d from the center of the nucleus. It's the same picture kaganina. I hope you can picture it out. Ako na we'll refer to this. Tara. The same gihapon siya picture. Okay. And the nucleus will be displaced a distance d from the center of the nucleus, I've said. And the force exerted by the electron cloud to the nucleus is just given by this. The same gihapon ng formula. So this is electron cloud. The force exerted by the electron cloud on the nucleus is given by this. So distance d. Okay. That will be the electric field uh, of distance d. Okay. Okay. So using Gauss's law. So using Gauss's law, the electron cloud, the electric field of the electron cloud will be given by this. So kanina mo siya nga formula. Always remember this formula sa inyong Gauss's law. So Q enclosed over epsilon naught. Okay. So we are looking for this expression. Can I see? So uniform naman ang electric field, ma-take out siya sa imuhang integral, so that becomes E, right? And then dA, that's your Gaussian surface. So the surface of the area of the surface of the sphere of radius d. So that would be 4 pi d square, right? And you have Q enclosed over epsilon naught. Your Q enclosed, so na isulat diri. So your electric field now becomes 1 over 4 pi epsilon naught d square Q enclosed, where Q enclosed is rho d tau. Okay. And then your rho is given by this. Tara. Right? Ano yung mga rho? So you substitute that here. So that would be according to nga. Okay. So your rho would be substituted here. So that would be Q over 4 pi epsilon naught d square. It would be 4 pi over pi a cubed integral r squared e to the negative 2r over a. Okay? Recall sa imong kuan kani siya. So na ako'y q sa gawas and ako'y pi over a cube sa ubos. Tara. So na gawas nga 4 pi here because ako nang i-integrate diretso ang di ba ana man ang bitaw. I have tulo man na siya ka integral. I have 0 to pi, 0 to 2 pi, and then 0 to r. So i-integrate na ako ang 0 to pi o 0 to 2 pi. That's actually cosine theta d theta. So if imuha nang integrate, then dp, that will give you 4 pi. That's okay, wala man kay symmetric na siya on that angle. So nagvary naman ang imuhang electric field along the r direction. So that's why ang r nga, because your density is dependent only on r and it doesn't depend on the angles phi and theta. So we'll have to integrate this. Okay, so we can consider integrating this one by using the formula. So use the formula. Kapag integrate ana, we have x squared e to the ax dx. And ang result niya is like this. X squared over a minus 2x over a squared plus 2 over a cubed times e to the ax. So if you ask me where did I get this table of integral, so you can always refer to the grade 9 or any book na nag-summarize or tabulate sa tanan integrals and unsay result. Okay? So we just have to use that. Okay, anyway, naa naman na siya gi-provide for us. Okay, so if we apply that here, so consider this one, consider itong integral sa imong electric field. Right, mamana. So if you apply that one, that would give you e to the negative 2r over a quantity. So d squared over negative 2 over a minus 2d over 4 over a squared. I hope nakapalo lang. Follow na kani nga formula. Plus 2 over negative 8 over a cubed. Right? I hope na-follow lang. Okay. And that is evaluated from 0 to d. Okay, your integral here is evaluated from 0 to d. Okay, so 0 to d. And if you do that, so ang details ana is kamo na lang solve sa inyong own convenient time, but I'll just give you the final result. So ang final result ana niya is a cubed over 4 quantity or bracket e to the negative 2d over a quantity 2d square over a square plus 2d over a plus 1 close parenthesis and then plus 1. So kana makuha na ninyo imo kamo lay solve sa inyong scratch paper, so in your own free time try to calculate this one from this point kanang naabot siya ani nga point. So evaluate naman na nimo ang imong limit. Okay, so that your electric field isubstitute na nimo. So this is the result man sa katong kaninga integral, right? Isubstitute na nimo here. So your electric field becomes 1 over pi epsilon naught b square a cubed. Okay, so we have a cube over 4. So di ba mawala siya a cube over 4, diba? So 1 minus e to the negative 2d over a quantity 1 plus 2d over a squared plus 2d over a. Okay, I hope ma-follow ra. This is minus the initial delay. Sorry. So this is minus 1. Okay. Then that's why we will have this form sa mga electric field. So imo ibaylo ang minus 1 diha because uh, this is actually negative. So na siya negative nga sign diha. Okay. So if you do that, you take out the negative sign and you get this kani sa inyong form sa inyong electric field. And then the A will cancel and other constants. So this is the electron cloud. That would be 1 over 4 pi epsilon naught A over B square. So 1 minus okay, so I have this form now. So after substituting or applying this e to the x in a form wherein x is very, very small. So in this case, this quantity here is very, very small since d is much, much lesser than a. So we can use this expansion sa exponential. So x would be negative 2d over a. So imo sa i-substitute diha. So we get this. That will be 1 minus, instead na kani, we'll have this sum or series. Okay? Times, you copy this. Kami lagi hapon. Right? So you can further simplify this. If imo na siya i-multiply bitaw, say this whole thing would be multiplied by this. And then you will find out nga na mag-cancel nga mga terms like ang 1 mag-cancel, ang 2d over a mag-cancel, and so on. So if you do that, I will leave that to you as an exercise that would simplify your equation as this. So q over d square. So ang mabiling na lang ana actually after those cancellation would be this. The d cube part. Okay? So you'll find out, notice niyo nga, mabili na lang is actually kanina lang siya ka-part. We have 1 minus, kanina lang siya ka-part ang mabilin. While the 1 mag-cancel, ang 2d over a mag-cancel. This one also will cancel out. Okay. So simply we have this equation. And then, ganun siya is masimplify pa man natin siya, di ba? So minus naman siya. So 1 minus 1, that would be 0. So 1, then this would be so we're just left with this 4 over 3b cube over a cube. And it's positive. So that's why we have 1 over 4 pi epsilon naught q over d square 4 over 3 d over a cube. And simplifying further, we have cancel ang 4, so we have 1 over 3 pi epsilon naught. Cancel ang d square din mabilis na lang is d. We have qd over a cube, or simplifying further, so this is electron cloud, this is cloud, That would give me 1 over 3 pi epsilon naught, where QD is just your dipole moment, right, over A cubed. So take note of this result, kaya ito na magamit ito later. Okay. So we can now have this relation, that is, ang imuhang external force is always balanced by this force sa imong electron cloud. Right? Opposite man sila nga direction. So the total force would be equal to 0. And the force due to the external field is given by this Q external plus Q, which is katong formula sa electric field, katong the E cloud, which is given by this. Tara. So you substitute that here. That would give you P over 3 pi epsilon naught A cube. So simplifying, we can get the P for this particular example. So let's label it as vector quantity na siya. So i-transfer mo sa P cross side, and then you get P as 3 pi epsilon naught A cube, then the external field. So this is your alpha. So alpha E external. So your alpha is 3 pi epsilon naught A cube. So with the use of a more realistic model wherein we consider nga ang um, the charge density of the atom is not uniform but instead given this by this distribution or function, you are able to get the polarizability of such an atom given by this form. So take note nga this is actually close to what we got, even though katong primitive nga model ato. For the primitive one, we actually got this. So medyo close siya, di ba? 4 pi epsilon naught A cube, and this is a more realistic 3 pi. So that confirms that sakto itong gibuhat. This is for how we do the calculation of uh, an induced, how to calculate the induced dipole moment for a given atom exposed to an electric field. So, so naturally, imuhang atom is not polarized, but because of the presence of the electric field, it becomes polarized, and kung unsa siya on how effective it is or kadali ma-polarize ang imong atom, that is dictated upon by this formula. So this is the atomic polarizability. Now let's consider this one. Let's continue. So if we try to consider the carbon dioxide molecule, oh no, not the carbon dioxide, but the water molecule. Okay, so let's try to consider the water molecule. So for the water molecule, it's not so simple compared to carbon dioxide and a simple single atom, because your water molecule is nonpolar. So nonpolar means it has partially nga positive nga part and partially negative. So a perfect example of a nonpolar a perfect example of a polar molecule is a water. Okay. So it's a polar molecule. page 4. So consider a polar molecule. Say this is a polar molecule, H2O. So for this case, water is already polarized. So actually, na siya what we call it built-in. So ang iyang pagka-polarize sa imong water molecule is actually built-in, not because of the presence of external electric field, but somehow na-effect ang electric field later on if imo siyang i-expose na siya ang electric field imong water molecule. But what I'm saying is your water molecule has a built-in, okay? Naa siya has a built-in or permanent dipole moment, right? So this is the your oxygen molecule kanina ko. So we have minus, and this is your hydrogen positive. Okay? So this is partially negative sa ubos, partially positive sa tataas. So the direction of your polarization is given by this direction, right? That's always pointing from the negative to positive. And notice na naa siya angle in between, right? And that's given by approximately 105 degrees, mga water molecule. So if imuhang tan-awon ang water molecule, let's say consider nimo ang kaning consider this one only, kani siya nga part lang, right? So this is your negative charge Q, and this is your positive charge Q. Let's say this is your origin, and this is separated by a distance D, right? If there is a presence of an electric field, okay, so na electric field diha, this is your electric field, what will happen is mo respond ang imuhang water molecule because of the presence of this electric field, right? So naman siya negative and positive, so na siya permanent dipole actually, built-in dipole moment. So this negative will move in this direction. That is always opposite to the direction of the electric field. And this one is positive, right? It moves in the direction sa imuhang electric field. Okay, that's the case. So if you have an electric field present in this system, and the two opposing forces, the F minus and F plus, actually balance out. So we can say that the F plus is balanced out by this F minus. So somehow stable gyapon siya. And they cancel each other. Right? So they cancel each other. So in this case, na ako'y force dinhi nga na ako'y force padulong dinhi, asad ko'y force padulong dinha, although balance out ang iyang force, right? But there will be a torque sa kaninga system, right? So in this case, there will be a torque. So your molecule, in response sa pag-expose sa electric field, it will try to rotate, right? So rotate siya. So the dipole moment will try to uh, align. So your dipole moment. So this is the direction initially sa imong dipole moment polarization, and it will try to align with this direction sa imong electric field. So mo rotate siya. Okay, mo rotate ang imong molecule until such time nga ang torque niya is zero. Until such time, or in other words, until such time ang imong polarization, ang imong dipole moment will be aligned with the electric field. Okay, so if you have a water molecule, say dahang kag nga water molecule, i-expose mo siya electric field, ang response sa mga kada molecule sa water will actually rotate. Okay? Will rotate because your water molecule is a polar molecule. It has a built-in or permanent dipole moment. So those molecules will rotate until all of those molecules, yung dipole moment, will align sa direction sa electric field. So rotation, that would mean na ay torque, right? So if we can denote torque as given by N, so that would be torque is, the formula for torque is, if you can recall sa inyohang physics, is tau man na, di ba? That's actually R cross F. And ang result niya is another vector quantity, ang direction kung asa ang torque, right? But the direction sa imong turning, ang direction sa pag-turn is it's either clockwise or counterclockwise. Now for this case, ang torque ano niya is in the onto the page ang torque, ang direction, but the rotation is clockwise. Okay, based sa kaninga nga scenario. So I have R cross F in this case. So ang turning sa kaning positive nga part sa imong dipole plus ang turning the torque contribution sa minus o sa negative charge, have R cross F minus, and this is plus. Okay. So that could be, your R is kani from the origin to the charge, that would be half. So 1/2 D cross QE plus 1/2 D. This time is negative sa minus because it's a vector quantity, opposite direction. Cross negative QE. That would give you, so imo na siyang i-add, right? This one. So, ang imong direction sa D and so direction sa Q. So, that would give me QD cross E. Right? And QD is just P. Okay? So, ang amount sa turning, kung usa ka paspas ang tuyok, actually, it depends on, of course, the dipole moment sa imong sa imong water molecule, and also kung unsa ka strong ang imong electric field. Okay? The magnitude of these, or the magnitude of the electric fields or the electric field strength, that determine kung how unsa ka kusog ang iyang torque o iyang turning sa imong water molecule. Okay. So we'll continue with our discussion. We'll stop right here sa kaninga part sa itong video, and then we'll discuss on generalizing on calculating the polarization of the material, not just on water molecule, but we'll apply it now to an insulator such as a dielectric material. Okay. Stay safe and cheers. See you on the next video.